Okay, in this example, we're going to do a simple resistor network, and our goal is to find the equivalent resistance RAB. If you look at this resistors network carefully, what you'll notice is that none of the resistors are actually in series or parallel to each other. So this is a slightly complex resistor network. So let's look at this resistor 1 ohm. This 1 ohm resistor is between node A and we call this node C. This 1 ohm resistor is also between node A but not with node C because there exists a resistor right here on 1 ohm. So this is between D. So this 1 ohm and this 1 ohm are not in parallel to each other. Similarly, the bottom 1 ohm resistors are not in parallel. So when you come across a problem like this where it is hard to decipher whether a network is in series or parallel or a mixture of the two, easy way to do it is to use nodal analysis. So for that, let's do this. Let's add a current source between node A and B, and we'll call that a 1 amp current source just to make our math easy. So we added a current source, so add current source. Now we're going to use nodal analysis. So that means we need to pick a reference voltage. Let's call VB is reference point. Okay, so that's equal to 0 volts. So all the calculations will be done with respect to that point. Now, what we know is we know the current is 1 amp. If we can find the value at VAB, which is equal to VA, since B is at 0, then we can find the resistance RAB as being VA divided by the current. We already know this. We can calculate this so that we can get a value for RAB. So let's see how that's done. Okay, so let's start out by doing a nodal analysis at node A. Using Kirchhoff's current law, the sum of the current coming into a network is equal to the sum of the current going out of the node. Okay? So from VA, if you look at node A, if you look at node VA, VA minus VC divided by 1 ohm plus VA minus VD divided by 1 ohm is equal to the 1 amp current coming in. So if you write this, you get 2VA minus 2VA minus VC minus VD equals 1. So let's call that equation 1. Okay. Similarly, let's do a nodal analysis at node B. Oh, we don't have node B, so let's do a nodal analysis at node C. Node C, let's indicate the arrows of the current. So VA minus VC is the current coming in divided by 1 is equal to the sum of the currents going out. So VC divided by 1 plus VC minus VD divided by 1. Let's rearrange everything to the left hand side. So we get VA minus 3 VC plus VD is equal to 0. We'll call this equation 2. Now let's do one more at node D. Similarly for node D, VA minus VD divided by 1 plus VC minus VD divided by 1 is equal to VD. And if we rearrange that, we get VA plus VC minus 3 VD equals 0. And we'll call this equation 3. So we have three simultaneous expressions. We have three simultaneous expressions and we have three unknowns, VA, VC, and VD. You can use any technique you want to solve a simultaneous equation and get a value for VA. So here, let me do this. For equation number 1 and equation number 2, let me add So let me solve. So this is me solving the expression. Add expression 1 and 2, and we're going to get 3VA minus 4VC, 3VA minus 4VC minus VD plus VD equals 0 is equal to 1. So let's call that expression number 4, and we'll come back to this. Now let's see. For let's multiply equation 2 by 3 and add to equation number 3. So we want to multiply equation number 2 by 3 and add to 3. So we get 3, oops, we get 3 VA minus minus 9 BC plus 3 BD equals 0. This is after multiplying this whole expression by 3. And now we want to add expression number 3 to that. So we end up getting 3VA plus VA, so 4VA minus 9VC plus VC is minus 8VC. 3VD minus 3VD is 0, so that's equal to 0. From here we get 4VA equals 8VC. In other words, VC is equal to VA over 2. Okay. Now let's go back to this expression right here. So let's use this and plug in the value of VC here. So we have 3VA minus 4 times VC is VA over 2 equals 1. So 3VA minus 2VA equals 1. In other words, VA equals 1 volt. We have I equals 1 amp. Therefore, the equivalent resistance or equals RAB is equal to VA over I is equal to 1 volt over 1 amp equals 1 ohm. So this is a technique to solve a complex network of resistors by using a current source and nodal voltage analysis to find the equivalent voltage and hence the equivalent resistance.